Hello ladies and gentlemen, I'm here to review your position versus time and velocity versus time graph review and practice worksheet. We went through this very quickly in class, but I want to let you have an opportunity to do it again where you can go back and see it and see it and see it again. So let's start off with number one. I think there's 6 on both sides of this sheet. So the first one, when we look at this, let's just do a real quick analysis of this position versus time graph that I've given you. We can see its position and time, and that it has a constant slope. It's a straight line, so we know that it's going at a constant velocity. So that really helps us. And we know that it's starting at 0 position and moving away from the origin. So we know constant velocity and away from the origin. So again, on a VT graph, above the line is away from the origin and below the line is towards the origin. So it's just a convention they use, and we have to just sort of memorize that. But once we do that, we can see that this is constant velocity away from the origin. So away is up here, and a constant velocity means that at any time that I check in on this line, it's always going to have the same velocity. So I just pick a point, a non-zero velocity point, and I draw a very horizontal line. And again, anytime I check in, no matter what time along the time axis, it's always going to have the same velocity. It's going to have a constant velocity. So that is what that one looks like. Let's go on to number 2. Number 2, if I look at this one, the position versus time graph, I can see that it's moving away from the origin, so it's going up the position axis. And it's starting at a gentle slope, and as time goes on, it gets faster and faster and faster. I can see that because the slope gets steeper and steeper and steeper. So we have an object that is accelerating. It is going faster and faster with time, and it's moving away from the origin. So if we draw the velocity time graph, I'm going to put it in like that. Here's velocity, here's 0 velocity, 0 time, and there's the time. So this one is moving away from the origin, and again, away is up here, and towards is down here. This one's moving away from the origin, and it's getting faster and faster. So I'm going to start something at 0 velocity. That's what that says right there, that this is the 0 velocity point. And then it's going to move away at a constantly increasing speed, or velocity, away from the origin. So if we look at this line, at this time mark, it's going closer to 0, so it's slower. As we move out, it's further away from 0 on the velocity axis, and it's going faster. So these two graphs match. Let's go on to number 3. Number 3, I've given you a velocity time graph, and we know again that this is away from the origin up here, and this is towards the origin down here. So this line is moving away from the origin. So let's go ahead and draw our position time graph axes. There we go. And we know that it's moving away from the origin, so we know it's going to be starting here and going something. And this is moving an object that's going faster and faster and faster and faster. So we know that that line is going to start off with a gentle slope, and as time goes on, it's going to get steeper and steeper and steeper. And if you'll notice, these are just mirrors of each other because it's a really important thing to keep in mind. Let's move on to number 4. This one's kind of a tricky one. I like it very much. It's very fun. So if we look at the position time graph, we can see that this line has 2 segments, A and B, but it's moving away from the origin on this position time graph. These lines are both straight, which means they have constant slope. So A has a constant slope, therefore a constant velocity. B has a constant slope, and therefore a constant velocity. So if we draw the velocity time graph, there we go, there's velocity, there's 0 times 0 velocity, there's the time axis. And so we know these are both moving away from the origin. So this is away up here from the origin, and this is towards down here, just to remind you. And so we can see that the slope of A is steeper than the slope of B. That means this is a faster line, and this line is an object that's moving slower, so faster and slower. So if we come over here to the velocity time and draw A, we're going to draw it starting somewhere away from 0 velocity, which would be standing still. And then when it switches to segment B, we can't go backwards in time but we have to show one that's closer to zero velocity, and it's going to look like that. So this is further away from zero velocity, this is closer to zero velocity. So let's say that's 100 meters a second, and this is 50 meters a second, faster and slower. And I just draw the dotted line just to show that there isn't any gap there. We don't really have to draw that. All right, that's what that one's like. Let's go on to number 5. We look at this velocity time graph. We can see this is away from the origin. Down here is towards the origin. This one's starting at a far away from the zero velocity, and as time goes on, it's getting closer to zero velocity, which means it's slowing down. So, and it's working in the away from the origin quadrant. So let's put a position time graph over here. There's 0. So this one is moving away from the origin, and it's slowing down. So we have to start down here, and this line needs to start fast, so steep, and then as time goes on, it's going to flatten out, which means that it's slowing down. Those two graphs match. Last one, number 6. We look at this one. This is a position time graph. We have two segments, A and B. A is moving away from the origin, and B is moving towards the origin on this position time graph. And this one is fast, and this one is slower. So that's how we can analyze that. So if we come over here to the velocity time, so there's velocity, zero velocity, and that's the timeline. And so we have one here. So again, this is on this side is away from the origin, and this one is towards the origin. So we know that segment A is pretty fast, moving away from the origin. So we'll start it up here, somewhere away from zero velocity, which would be right here. This whole line on velocity is zero velocity, standing still, not moving. Now B, though, is moving towards the origin, so we have to come down here and to the toward the origin side, and it's moving slower, so it has to be closer to the zero velocity line, and it will look like that. So this one's faster, this one's slower, because this one is closer to zero velocity. This one is away from the origin because it's on the away from the origin side, and this one's towards the origin because it's on the towards the origin side. Thank you so much, and please feel free to review this.